Good morning, students. So today I am going to present you a lecture on the topic that is abstract classes and methods. Now you remember in one of my earlier presentation I have discussed about the features of object-oriented programming system. Now out of all these features I have already explained you about the first feature, that is polymorphism, the second one which is encapsulation, and the third one which is inheritance. Now today I am going to discuss about the last feature of the object-oriented programming system, which is abstraction. In the Java programming language, abstraction shall be implemented with the help of abstract classes and methods, and that I am going to explain you with the help of a Java program. I have also discussed that polymorphism is of two types, which is static polymorphism and dynamic polymorphism. The static polymorphism is implemented with the help of method overloading. Okay, the static polymorphism is implemented with the help of method overloading. So what was method overloading? Method overloading was the concept of defining more than one method with the same name but different signatures. In the following Java program, for the class named calculator, there are two member methods, both bearing the same name sum, but their signatures are different. This is because for the first member method sum, their arguments a and b are of integer data type, but for the second member methods bearing the same name sum, their arguments a and b are of floating point data type. That's why their signatures are different, and this concept is called method overloading. And since this program has method overloading, it has static polymorphism, as static polymorphism is implemented with the help of method overloading. Now, just as how static polymorphism is implemented with the help of method overloading, the dynamic polymorphism is implemented with the help of abstract classes in Java, and that I'm going to show you with the help of a Java program in my today's presentation. Now coming back to today's presentation, so let's get started with abstract classes and methods. At first you need to know what is abstraction. Abstraction is one of the very important features of object-oriented programming system. It focuses on only the relevant feature of an object. We practice abstraction in our daily lives. For example, we can see abstraction in an automobile showroom. Now take the case of this example. A car has many features, but the salesman talks about the speed of car to that customer who is more concerned about speed. And again, the same salesman talks about the mileage of a car to that customer who cares about mileage. So what's happening here is actually the salesman is practicing abstraction by only revealing the features of the car relevant to a particular kind of customer. That is, for the customer who cares about mileage, the salesman talks about the mileage of a car, and for the customer who is more concerned about the speed, the salesman talks about the speed of a car to that customer. In this way, the salesman is practicing abstraction by only revealing the features of the car that is relevant to a particular kind of customer. In the Java programming language, abstraction is implemented by defining the empty methods in a class called abstract class, and that I'm going to show with the help of a Java program. Now let's come to the topic abstract class. Abstract class exist conceptually and they cannot be instantiated. In the given figure, you can see that there is a base class called shape, which is inherited by the classes circle, rectangle, and triangle. In practice, we cannot draw a shape. Whatever we draw will have a name like circle, rectangle, triangle, or whatever. It can be even a line or a polygon, etc. Hence, the class shape can be defined as an abstract class because it exists only conceptually, which cannot be instantiated. Only the objects circle, rectangle, and triangle for this abstract class shape shall be instantiated. Now once you have declared an abstract class, that abstract class must have one or more abstract method. Now first of all, what is an abstract method? An abstract method is any method which have no body, and it is declared using the abstract keyword in Java. Now see this Java program. In this program, a class has been specified the name furniture, and this class has been declared abstract. And since this class is an abstract class, it must consist of one or more abstract method. Let's find it out. Let's search for the member methods. The first method is furniture. Now that its name resembles the name of the class, this is not a usual member method. This is a constructor method. Then again come below, there is another member method which is show, and its return type is void, and yes, this is an abstract method because it is specified by the keyword abstract. So for the class furniture, we have got one abstract method which is public abstract void show. Now I am going to show you a Java program to demonstrate the abstract class, abstract methods, calling base class constructors, and implementing the dynamic polymorphism using abstract class. And here is this Java program. The Java program has a class specified by the name furniture, and it has been preceded by the abstract keyword. So that's why this class furniture is an abstract class. Now enter inside the body of this abstract class. At first, the data members width and height has been declared of data type int, and they have been given the protected access specifier. So here is the abstract class furniture having width and height as the data members of type int and protected as the access specifier. Next, there is another data member that is color of type string. Now this data member has no access specifier, so by default the access specifier which will be set for this data member color is friendly. So here is this data member color of type string, and the access specifier that will be set to this data member by default will be friendly. After that, you have two member methods. The first member method resembles the name of the class, which is furniture. That's why it's a constructor, and inside the body of this constructor there are three Java statements which need to be executed. So these three statements are inside the body of this constructor called furniture. Then after that, you have another method called void show, and this method have been declared abstract, and the access specifier which have been set for this method show is public. So here is this member method void show which have been declared as abstract under the public access specifier section. Now that the constructor having the arguments w, h and c was not set any access specifier, that's why by default the access specifier for this constructor will be friendly. You can see clearly here the constructor was not specified any access specifier. Now after declaring these data members, the constructors and the abstract method, the body of the class ends here with this closing brace. Now just after this class called furniture, another class called chair have been declared, and this class extends or inherits the features of the class called furniture, and this is represented here. The class chair inherits or acquires the properties of the abstract base class furniture. This class chair has got one data member, that is number of wheels of type int, and since no access specifier has been set for this data member, so by default the access specifier will be friendly. And here is the data member set for this class chair, and no access specifier has been set for this data member, so by default it will be friendly. Then after that you have two member methods. The first member method resembles the name of the class, which is chair, so it's a constructor, and this constructor has been set the public access specifier. Okay, and inside the body of this constructor, two Java statements are there. Okay, so they need to be executed, and that's why you can see it clearly in this block diagram that the constructor chair have been declared under the public access specifier section. Then after the constructor there is one more method, which is public void show, and since this method show have been set the public access specifier, that's why in this block diagram you can see that the method show have been declared under the public access specifier section. Now if you come inside the body of this method, these are the set of Java statements that needs to be executed, and once these Java statements gets executed, close this body of this method, then close this body of this class called chair. Then from here just go to this arrow pointer, come over here. Then again another class specified by the name table has been declared, which uses the extends keyword to inherit or acquire the properties of the abstract base class furnisher. And in this block diagram, here is this derived class called table, which acquires or inherits the properties of the abstract base class furnisher. Now this class, that is table, has got one data member, number of legs of type int, but no access specifier has been defined for it, so by default the access specifier defined for number of legs will be friendly, and it's represented inside the body of this class table like this: int number of legs followed by semicolon. Then after declaring the data member, this derived class table has got two member methods. The first member method table resembles the name of the class, so it's a constructor, and I have commented it like this. Inside the constructor, two Java statements needs to be executed. Now once the constructor gets executed, there is another member method which is show, and its return type is void, and it has been set the public access specifier. And same for the constructor table, which have also been set the public access specifier. That's why both these methods, that is the constructor method table and the ordinary method void calci, have been set the public access specifier. Now what type of inheritance have been furnished by this abstract class furnisher, then is derived class chair and the derived class table. The type of inheritance that is furnished by these three classes, that is furnisher, chair and table, is the hierarchical inheritance, because when the derived class chair inherits or acquires the properties of the abstract base class furnisher, and also the derived class table when it acquires or inherits the properties of the abstract base class furnisher, we can say that multiple derived classes are acquiring or inheriting the properties of a base class. And when multiple derived classes tries to acquire or inherit the properties of a base class, such type of inheritance is known as a hierarchical inheritance. So this figure, if you see, it forms a hierarchy. Same here in this Java program, the classes furnisher, chair and table forms a hierarchy. when the class chair inherits from the class furniture and the class table inherits from the class furniture, and this type of inheritance is the hierarchical inheritance. Now see, in addition to these three classes, that is furniture, chair and table, there is one more class specified by the name demo. This class contains the main method, and since main is the starting point of execution of a Java program, hence the class demo will be the point of execution. Now let's execute this Java program from this class named demo. Enter inside the body of this class demo, execute this main method specified as public static void main. Come inside the body of this main method, see the first statement, that is furniture f. Here f is an object which has been created for the class called furniture. Now as soon as the object f for the class furniture gets created, the control will shift from the here to the class called furniture, and then it will invoke or call the constructor for this class called furniture. So here is this constructor. This constructor has got three arguments, w, h and c, whose values shall be supplied to the data members width, height and color. But as of now, the values from the arguments cannot be supplied to the data members width, height and color. This is because when the object f has been created for the class furniture, it was not instantiated. Only in the next line the object f have been instantiated with the help of the new keyword, and the object f have been instantiated with the derived class chair. And now that the object f, which have been created for the class furniture, have been instantiated with the derived class chair with the help of the new keyword, so the control will now shift from here to the derived class chair, and now it's going to find out and invoke the constructor for this derived class chair. Here is this constructor. Now this constructor chair has got four arguments, w, h, c and w1, where the value of the argument w will be supplied from here, which is 10. So let me specify it here that it is 10. The value of the argument h will be supplied from here, which is 5. So let me specify it here as 5. The value of the third argument c will also be specified from here or supplied from here, which is red. So let me specify it here as red. Again, the value of the fourth argument w1 shall be supplied the value 3. So let me specify the value 3 for w1. Okay. Now once you specify the values for the arguments of this constructor chair, enter inside the body of this constructor, execute the first line. The first line says super, and it has got three parameters, w, h and c, where w will get the value 10, h will get the value 5 from here, and c will get the value red from here. Okay. Now what actually is this super keyword? The function of this super keyword is to call the base class constructor. Now for the given class chair, the base class is furniture, so we have to move to the base class, which is furniture. Now, which is the constructor for this base class furniture? Since we are required to call the base class constructor with the help of this super keyword, so we'll move to the base class furniture for this derived class chair, and now we will locate the constructor for this base class furniture, which is this. Now we will invoke or call this constructor. Now with the help of this super keyword, what gets invoked is the constructor of the base class, which is this. Now this constructor has got three arguments, w, h and c. The argument w will get the value 10 from here. Okay, so let me specify 10 here. The argument h will get the value 5 from here, so let me specify 5 for h, and the argument c for this constructor furniture will get the value red from here, so let me specify red here. Okay, now come inside the body of this constructor. Now assign the values from the arguments w, h and c to the data members, which are width, height and color. Now as the value of the argument w is 10, so 10 will be assigned to width, and as the value of the argument h is 5, so 5 will be assigned to height, and as the value of the argument c is red, so red will be assigned to color. And after this, the body of the constructor ends, and once the body of the constructor ends, the control will shift to this position again. Then again it will move to the next line just after the super keyword. The next line says number of wheels equal to w1. That is, the value of the argument w1, which is 3, shall be assigned to the data member number of wheels. So let's specify the value of w1 as 3. Now this ends the body of the derived class constructor. Now so as the body ends for the derived class constructor, the control will again shift from here to here, and then it will move to the next line, and in the next line it again uses the object f for this class furniture to call the member method show, and it does it using the help of dot operator. Now when you invoke this member method show with the help of this object f of the class furniture, automatically the controls should shift to the class furniture and invoke this member method, that is public abstract void show. But there is a problem. This object f, even though it has been created from the base class furniture, it's not going to call or invoke the member method show from the base class furniture. That is, it's not going to invoke this member method. This is because just after the object f have been created for the class furniture, it has been instantiated with the derived class, which is chair, with the help of the new keyword. That's why this object f, instead of invoking or calling the base class method show, it is now going to invoke or call the derived class method show, that is this one. Since the object f had been instantiated with the derived class chair, so this object f is going to call the derived class method show for the class chair. Now the control will shift from here to the derived class method show. Now enter inside its body. The first statement to be executed is this. The statement says system.out.println, which prints the text displaying chairs details, and since this text is within inverted code, it shall be displayed exactly as it is in the output. That's why under the output you can see this text displaying chairs details exactly as it is. Then come to the next line. The next line prints the text width equal to, which is within inverted code exactly as it is in the output. So in the output you can see the text width equal to getting displayed exactly as it is. Now along with this text width equal to, something has been added with the help of this plus symbol, the value of the data member width. Now that the value of the data member width is 10, okay, since the value of the data member width is 10, so the value of width will be 10, which will display the text width equal to and then the value 10 in the output section. So this is what appears in the output section, that is width equal to 10. Again, the next statement prints the text height equal to within inverted code, and then it adds the value of the data member height, which in this case is 5. So what gets displayed in the output is the text height equal to and then the value 5. So that's why you can see height equal to 5 in the output section. And then again this statement prints the text color equal to, which is within inverted code exactly as it is in the output, and then the value of the data member color will be shown, which is nothing but red. So what gets displayed in the output is the text color equal to exactly as it is and then the value of color, which is red. And that's why in the output section you can see the text color equal to getting displayed exactly as it is and then the value of color, which is red. Then come to the last statement of this method. It prints the text number of wheels equal to within inverted code. So this gets printed exactly as it is in the output. Along with that, what gets added is the value of the data member number of wheels. In this case it is 3. So number of wheels equal to 3 gets displayed in the output. That's why you can see in the output the text number of wheels equal to 3 gets displayed. And once this member method gets executed for the derived class chair with the help of this object f for the class furniture, the control will come over here and again it will move to the next line. In the next line, the same object f which have been created for the class furniture will now be instantiated with another derived class. Okay, the object f shall be instantiated now with another derived class. Now this time it's not chair, it's table. So from here the control will move to this class, that is table, and it will call the constructor for this class table, which is this. Now the values for the arguments of the constructor, that is for the arguments w, will get the value 8. So let me specify 8 for the argument w, and again for the argument h the value to be supplied will be 16. So let me supply 16 as the value for this second argument h of the constructor. Then for the third argument c, the value to be supplied will be blue. So assign blue as the value for the third argument c of the constructor table. And again, for the fourth argument L of the constructor, supply the value of 4. Then come inside the body of this constructor, execute these two statements. The first statement to be executed is the super keyword. So control will come over here. Now the function of this super keyword, as I have already explained, it will call the base class constructor for the derived class table. So which is the base class for this derived class table? This is furnisher. So the control will immediately go to this base class furnisher. Now it will call the constructor for this base class, which is furnisher. Here is this constructor because its name resembles the name of the class. Now in this constructor, the arguments W will now be specified with the value 8 from here. So instead of 10, it will now be 8. The value of 8 will be specified from here, which is 16. So instead of 5, it will be 16. And the value of the third argument C will be blue, specified from here. So instead of red, it will be blue. Okay, now enter inside the body of this constructor. Now width will be assigned the value of W, which will be 8. So 10 gets replaced by 8. Then in the next line, the data member height will be assigned the value of 8, which is 16. So 5 gets replaced by 16. And then again come to the next line, the data member color will be assigned the value blue from the argument C. So instead of red, the value blue gets stored in color. And this ends the constructor. And once the body of the constructor ends, the control will again shift from here to this position, and again it will come to the next line. Here it is going to use the same object F to call the member method show of the class furnisher. Now is it going to call the member method show for this class furnisher? That is it going to jump from here to the class furnisher and call the member method show? No, it's not going to do that. This is because the object F, even though it has been created for the class furnisher, this has been instantiated with the derived class table with these values. So now instead of calling the base class member method show, it's now going to call the derived class member method show, that is for the derived class table. So the control will now shift from here to the derived class table, and it will now locate the member method show here. Then come inside the body of this member method, execute the first statement, which displays the text displaying tables details exactly as it is in the output. And that's why in the output you can see this text displaying tables details exactly as it is in the output. Then in the next line, it prints the text width equal to, followed by the value of the data member width, which comes to width equal to, the value of width in this case will be 8. So width equal to 8 gets displayed in the output, which is shown here. Then again come to the next line, it prints the text height equal to exactly as it is in the output, followed by the value of the data member height, which in this case is 16. So height equal to 16 gets displayed in the output. So here it is, height equal to 16. Now again come to the next line, it prints the text color equal to exactly as it is in the output, followed by the value of the data member color. So it prints color equal to, as we know the value of the data member color is blue, so color equal to blue gets displayed exactly as it is in the output. Now again come here to the last line of this member method show. It prints the text number of legs exactly as it is in the output, as it's enclosed within inverted code. And then what gets added with this is the value of the data member number of legs. and as we know, the number of legs will be assigned the value from the fourth argument, that is L. And what's the value of the fourth argument L? It's 4, isn't it? So 4 will now be supplied to number of legs. So in the output, we'll see number of legs equal to 4. So that's what you see here in the output. And this ends the body of this member method as well as the body of this derived class table. Now the control will shift from here. It will again move to this position, and it will close this main method here, and it will close this class demo which initiated the main method. And the output that you have got after executing that program was this. Now keep in mind that since this class furnisher have been specified as abstract, that's why it should contain one or more abstract method. As it contains one abstract method, so that's why this class furnisher is an abstract class. Another thing you need to note that methods which are specified as abstract does not contain any body. Okay, that means for this method we will not have any body which will be enclosed within opening and closing curly braces like this, and there shall not be any Java statements to be specified here. Okay, so this is not acceptable for abstract methods. So body is not allowed, and that's why abstract methods should be ended like a ordinary Java statement with a semicolon. So with this I end my presentation today.